Hi, I'm Tom Stevenson, and welcome to Construction Project Management Principles. Today we're going to be looking at first order and second order consequences, the costs that we incur when sometimes we just look at the first order consequences of something we do, which usually means we're looking at the advantage of something, like it's a shiny object, like it's a big cost savings, and of course, we go after that shiny object. I'm a professor of construction management, and I've had years of experience working with much smarter people than myself, and I've learned a lot from them over the years. So hopefully today's lecture will give you a bit of insight on things that you should think about with regards to first order consequences, second order consequences, elimination of waste. And I'm going to use Microsoft Project in the mix just to sort of set the example of how you could compare one thought process with another process and see the variances and differences. Okay, so let's get started. Let's start thinking about what is a first order and second order consequence to begin with. Usually when you say that, it kind of gets people blurry-eyed, so to speak. But really what we're talking about, the first order, it's like very clear. You do this, you get that. And so first order, that's the advantage of it, but sometimes it's the disadvantage because you just look at that huge advantage, right? So you get immediate and direct results if you do something. Now, the second order are the subsequent effects. Well, you did this, but this is now causing something else to happen. And it doesn't only have to be one thing, it could be a multitude of things. It could be second and third order. It could be multiple second order kind of consequences. Some second order consequences could be building on the first order consequence, meaning it's actually making it even better. You know, you did this and then that happened and then that happened and then this became this and it's positive. But sometimes it can, in construction particularly, it could be, yeah, we went for this, but I don't know, maybe we shouldn't have done that. And so that's what I want you to start thinking about, how we approach basically the things that we make decisions on. So first order consequence, here's an example, right? So I'll give you a few examples, and then we'll look at a little case study. Cutting costs by using cheaper materials. Like we know that can be problematic. In some cases, it can be okay because sometimes it's maybe you're using a less expensive material, maybe because the brand name isn't quite up to the same speed. But as far as quality goes, longevity goes, it's very similar. I've had examples where, a client wanted a certain type of kitchen cabinets because it had this name to it. But honestly, it was still made out of melamine. The raised panel doors were lacquer finished. The other cabinets were lacquer finished. There really wasn't a big difference other than the name of the first one, which was quite a lot more expensive. In a case like that, that might be okay. Rather than using the more expensive one, you're saving on the budget, right? But oftentimes it can mean lower quality. Very often it means lower quality and durability. So if we do that, just take an example like roof shingles. If you get a roof shingle that has a 20-year life expectancy or a 30-year life expectancy, what's the cost difference? What's going to be the difference in changing those shingles in 20 years? Now, the question would be, are you still going to be living in that house and will it really matter? So those are other questions that you'd want to ask in that situation. But if you're a building or facility manager, say for a office building or a college or university building, and this is going to be a long-term building, then it might make a lot more sense to go with a more expensive type of roofing membrane, probably flat roofs in those cases, right? Because the extra cost of changing it, in 12 years, especially if you're talking flat roofs, 12, 14 years, that can be quite substantial. So there's the life cycle cost of what this particular product is, but it's also thinking of the second order consequence. Well, it might not be your consequence if you're selling the building, you're a developer. Then that's not real. If you're a developer selling houses, well, unless there's a big difference in the look and you're able to command a bigger price for it, it probably doesn't make sense for you to put a longer lasting shingle in those cases, even though for the homeowner it would have been nicer. So yeah, there's second order, lower quality durability. increased maintenance costs, more frequent repairs and replacements. So those are thoughts, right? And so in the design process, an owner, facility owner, will think a lot differently than, say, a developer will, which makes sense. But understanding that nuance is good. First order, second order, rushing through the planning phase to meet a tight deadline. This is something we do all too often in construction. We have these design bid build competitions, right? You get awarded the contract and you say that in your original schedule, you say you're going to get the letter of intent and then you're going to start doing all this stuff right away because that helps you to secure the contract. But the reality is, if you're rushing that fast on the planning phase, then it means you're going to be more in reactive mode during the execution phase. And so that will tend to really cost you a lot of money because the biggest opportunity to save money is in the planning stage, right? Actually, the biggest opportunity to save money is in the design phase, the early design phase. That's where our contract models have some issues because owners typically want to design bid build because they think they're going to have a lump sum price, but then they end up having a whole bunch of change orders, which has a lot of ripple effects onto the project. So second order consequences are poorly thought out designs and plans. Another second order consequences, delays, budget overruns during construction due to unforeseen issues that could have been addressed in the planning phase, in the design phase. The earlier, the better. And that means so much. There's an excellent book on how big things get done by Bent Flyberg, and it's on mega projects, billion-dollar plus projects. And he's got the world's biggest database from Oxford University on mega projects. And it's astounding how few mega projects finish on time and on budget. We're talking way less than 1% and adding the value that it was intended to add to the project. And one of the biggest things that he's discovered in his research is that rushing through the planning phase, not incorporating the right inputs in the design phase. So I like the Navy, and you've heard me use it before on this channel, right? Being a professor of construction management, I read a lot in this particular area, and I really like the military saying that goes slow is smooth and smooth is fast. And in construction, it's really important to understand there's a first order consequence. Okay, we rush the planning phase because it looks like we're getting something done. It looks like we're doing something. So that looks positive, right? The client's going to be happy. It looks like we got boots on the ground. But it's not much good when you got to do a bunch of stuff twice. It's not much good when you missed a lot of stuff. It's not much good when things aren't sequenced properly. So that's a big consideration, differentiating first order and second order consequences. I've got this example in this case study that I want to use, that I do an assignment with my students, and just recently I did this assignment. And it's regarding ordering materials and inventory. So I want to basically sort of outline the case for you, and then I want to sort of show you a little bit of Microsoft Project, and then I want to talk a little bit about how it compares to the 8 areas of waste that we discuss very often, especially in the lean construction world. And it's a great way of sort of categorizing how we waste things and often don't think about it. It's a great tool and a great way of thinking on those terms. All right, so we're ordering materials. First order consequence. Well, it's probably positive, right? If we've got this opportunity that we could take advantage to a huge discount if we take the delivery of the materials sooner. Probably we're getting that discount because the supplier, it's taking up space in their yard. They want to get rid of all of this material as soon as possible, and they're willing to give you a discount to take it, okay? Second order consequences, well, there's generally increased storage costs, and we'll unpack that a little bit due to the need of additional warehouse space or other spaces, which we'll talk about. You do have a second order consequence. The last number of years, there's been a lot of supply chain issues and there's a lot of inflationary issues, which we didn't really have in the period going back 4 or 5 years. But more recently, we've had a lot of inflationary pressures. And so if you bought it now with this discount, you don't have to worry about it going up 10%, 20%, 30% in some cases in the coming months, right? You've got it secured. On the other hand, you could have the reverse that happens if and I've got inflationary pressures there. I would say deflationary pressures. So if the price actually drops, you could basically be, well, you already paid for it. Now it dropped, you could have got it a lot cheaper. I would say that one's probably a less likely one. This one currently probably is maybe a little bit more, although it's kind of stabilized. But they are things that you want to consider depending on the time frame that you're in and what's exactly going on in your industry, your sector. And I'm talking within trades, I'm talking within materials, commodities, copper pricing as an example, if you're an electrician. So these types of things come into consideration when we're thinking about the consequences. So I've got this little case study here, and I'll just read through it quickly. Don't worry about the small print, but basically you're a new project manager for the electrical trade, and you have just begun planning for the renovation of a 3-floor office building. You've got this opportunity, interesting situation has arisen whereby the supplier you intend to purchase the lighting fixture package from has offered to discount the entire lighting fixture package by 5%, provided you're willing to take delivery of the entire fixture package once the approvals have been granted. So you look at that and you feel that the approvals will take 5 weeks. So the earliest you could expect to receive the entire fixture package would be 5 weeks. All right, you're new in this role. And of course, you've learned that successful projects are ones that are completed within time, allocated, and under budget. In the interest of saving a substantial amount of money, the project manager, you are seriously considering taking delivery of the fixtures. And I want you to think about the fixtures like they're these a lot of them, I'll show you a material list, but like 2 foot by 4 foot, they're going in T-bar ceilings. There's a lot of rooms that are going to be renovated, and there's a lot of these fixtures that are going to be as part of the opportunity or the request that you're going to be putting in for. And so I want to take a look at the schedule in Microsoft Project. And so I'm just going to switch over now to Microsoft Project, and then we'll look at some of the cost implications. And then we'll talk about the fixture package and its size implications. We'll look at that and we'll compare, what is it if we take it early and what is it if we take it at the normal time. So let's take a look. Okay, so we're in Microsoft Project, and I know a lot of my viewers use Microsoft Project and they watch my videos on Microsoft Project. So I thought it's also helpful to just show how you can use it as a tool for doing a little bit of sensitivity analysis or for decision making on certain situations. And so I've got this little office project that I've sort of set up here, and we've got our pre-construction, we've got our construction of our work breakdown structure here, and we've got essentially electrical rough-in floor 1, floor 2, floor 3, and the activities that are involved. We've got our critical path going over here. And we've got this original light fixture order and delivery that I've got placed here. And what I've done is in the resource sheet, just kept it simple here for this example, but I've created a few variable costs that I'm going to assign to the project overall. And then I've got this lighting package, which I've got at a cost. And we said that, or if I didn't mention it, the lighting package is $150,000. So that's the current price for the lighting package. Now we can potentially save 5%. So 5% of $150,000 is $7,500. Now, what it did say is that we would have to take this light fixture package at day 25. All right, instead of day 80, because that's when all the submittals, everything would be approved. That's the earliest that we can take it, but we would agree with the lighting supplier and then we would get that discount. Okay, so first thing I would want to make sure is that I've set a baseline. I might have already done that, so I'll just go to project, but just to make sure that we've set the baseline. Remember a baseline, no, I haven't. Set the baseline for the entire project. That's taking a snapshot of all the costs, all the times. So if we change something, we can see the difference. Okay, so I'm going to go, okay. So I've just set that baseline in there. And now what I want to do is I want to, well, maybe I'll take a quick look here at the cost screen. And I can see right now these are our total costs that we've got on this particular project. So this is including the cost of our PM, project coordinator, and site super, which we've applied to the whole project. And it's also including the price of our original light fixture order and delivery. So what I want to do is I want to change this to 25 days. We're in the cost screen right now. Oh, and by the way, let's see what kind of variance that we have here. So we've got a variance, not a variance, a float here between the blue and the red. So let's take a little look here. I'm just going to go to my schedule screen. I just click up here in the square, basically a square icon box, right click, and I am going to go to my schedule screen. And in the schedule screen, I can see that I have 3 days of float here. So I've got 3 days of float here. Okay. So what I want to do is I want to change this, and I could change this in whatever screen I want, as long as I've got the duration column. I put the duration column in here, and of course, you can always customize your columns in Microsoft Project by typing the first letter of what it is and inserting it there, but I don't need it twice, so I'll just remove it. I'm going to change this from 80 days to 25 days. Okay, and you'll notice that essentially this now has a lot of float, right? So this has a lot of float, 52 days, and essentially this has now 0 float. All right, so it's also basically from a point of view on variance, it saved us 3 days. It saved us 3 days. So that's a good thing, because if it saved us 3 days, that means we are going to have our management team, right? Basically our PM, our project coordinator at site super, they're going to be there 3 days less. So that's going to save us $7,680. The other thing is, if we are now going to take the discount, because we're taking it early, and it's a 5% discount, then I'm going to change that. I'm going to lower this number here to $142,500, because we are saving $7,500. 5% of 150 is $7,500. All right, so we've just got a savings of $7,500, which is giving us a total variance saving, because we had that 7,000, whatever that was exactly, with the PM, the site super, and the project coordinator. So now we're at a savings of $15,180. So, that's what we could be thinking about, that by doing this, we have a savings of $15,180. Let's go back to our PowerPoints, and we'll discuss a little bit, well, how does this, because this looks great, this looks fantastic, right? Well, let's think about this now. This is the list for basically the lighting fixtures. And so we're going to have 350 units. And I put this photo here so that you could sort of visualize, like these are your 2 foot by 4 foot, right? And they're usually about 4 or 5 inches thick, depending on the model. And we're going to need 350 of them. These ones are 2 foot by 4 foot as well. These are 2 foot by 4 foot as well. These are a little bit smaller, 2 foot by 2 foot. And then we've got a bunch of other fixtures and equipment. You have to visualize how much space this is going to take up, or you have to figure it out if you know the size of the boxes. The other thing you have to realize, these come in boxes. Think of Amazon when Amazon delivers something to you. Sometimes you're taking something out, there's a box in a box in a box, right? Well, this won't be that bad, but it will definitely be a box, and there's likely going to be styrofoam around each box, which means the box is bigger than the actual light fixtures themselves. So it's not even exactly 2 foot by 4 foot. It's going to be a bit wider, a bit thicker, a bit longer. And it's going to be a substantial amount of space that's going to take up. So the next thing you got to ask yourself, okay, well, we're going to save about $15,000 on this thing. What are the second order consequences that we need to consider? Where are you going to put it? Is there some space that you have that is big enough to store this in? Is it secure? Could stuff be stolen? Are you going to have to move it more than one time? Every time you move it, it takes people to move it. If there's not space, are you going to rent space to store it? Are you going to rent some sea cans to put it in? How many sea cans would you need to put it in? What would be the cost of that? What would be the cost of the extra movement? Could it be stolen? Could it be damaged? Moving it multiple times. The labor costs of that. These are all things that you need to look at in this particular situation. This was actually a picture of one of the classrooms in my college, and it's a great example of work waiting for workers, because this started, I think, before the holidays. It's been empty ever since the holidays, that's for sure. And, you know, we're a couple of months into it, and it's just sitting there, right? Waiting for the next trade to come in, or something that has delayed it, right? That's a waste when you have something sitting there for that long, particularly if, say, the college contracted a contractor to do it, and we had a bunch of schedule changes and stuff. If it was supposed to be ready, those classrooms, by January, and they weren't, then that causes undue hardship on the college in their scheduling of rooms, on students in their use of rooms, and that makes for more adversarial relationships between contractors and clients. All of these things are possibilities in differing situations. I'm not sure the particular situation in this case, but generally those are the types of things that go on when you see that. And it's probably the contractor is very busy, or they're having trouble getting a trade, or it could be on particular materials. So these are considerations that we need to think about when we talk about first order and second order consequences. So we save $15,000, but we should be thinking about the 8 areas of waste when we look at this. You know, if some of those light fixtures become damaged by us storing them somewhere, then it's the same thing. You got defects, you're going to have to order new ones, replacements for the ones that were damaged. So that's a problem. Or if they got stolen, a bunch of them, then that's also rework getting them delivered, paying for them a second time. That's always an issue. Now, not all 8 areas of waste, which spell the word downtime. I'm going to do another video on the 8 areas of waste coming up, because I feel like I haven't really unpacked that enough. But basically, it spells the word downtime from lean construction methodology, but from any kind of viewpoint, this is waste, right? Producing more than needed probably wouldn't be too big of an issue. Like if there was a change in some of the quantities of fixtures or something like that, you could charge for that in a change order. So you could likely recoup those costs. But it wouldn't be very good for the client, because you'd have to charge a lot extra for those costs. So again, getting things delivered at what we would call the last responsible moment would be much better, right? I'm not saying you can't take this early, but I'm saying you shouldn't take it early unless you really looked at the numbers. And honestly, if the numbers are anywhere near close, you should be thinking about how is that going to impact overall in reality, and what risks are we taking. That example I showed you in the slides was really, with the Microsoft project, was really just showing the electrician's layout of the schedule. So if I'm the electrician, I'm thinking of optimizing for myself. So I'm thinking of optimizing for myself. So if I go back a couple of slides here on the electrician's example here, so you can see these are just electrical. If I'm just looking at the electrical, right, and I have good storage and it's close by, this is probably not looking too bad for me, because I've got this amount of work. I've got when I change this, it shortens this so that this becomes critical. I save 3 days. I save $15,000. So from an electrician's point of view, this looks not too bad. This looks like it's a reasonable possibility. But from a project point of view, what else is being integrated here? Where are you storing this? You're storing in another room? Is that a room where the HVAC is getting roughed in? Is that a room where the plumbing is getting roughed in? And then they can't do it, so they have to move everything, and then you have to move it again. That is a big, big cost. And every time you're moving something, did something get lost? Did something get damaged? Did something get stolen? So there's a lot there from that perspective. So if unless it's looking like you're able to put it and it just makes perfect sense, this $15,000, if you're starting to rent sea cans for this in several months and storing it in it, that $15,000 with basically dropping it off, moving it again, it doesn't take long before you've spent that. And so that's, even though it looks pretty good, that may not be so good from that perspective. And of course, if you've got essentially what you've got there, when you've got the lights sitting in a room, you've got work waiting for workers, right? You've got the lights waiting to be installed. And that anytime you have long periods of that tends to interrupt the flow of work in a multitude of ways. So we have to think about it from those terms. So really the topic when we're looking at this one in downtime in the 8 areas of waste, transportation, when and where, right? That's really the crux of it. Are we able to get it when we want it and where we want it? And I'm going to say in this case, you're getting it way too soon. So you got to really look at, is that number, when you consider all the other effects, really going to be that much effects and possible risks, going to be worth it? And so inventory, how much? The other question is, looking back at that schedule, we've got 3 different floors. It might make a lot more sense to have 3 deliveries in reality for those materials. It might make a lot more sense to have 3 deliveries for those materials instead of 1 big delivery, 1 for each floor. And if the floor is huge, you might even want to consider 2 deliveries per floor. You want to have enough lights that are going to stay ahead of the electricians, so electricians don't have to have workers waiting for the lights, right? But you don't need that much, especially when it's such big, bulky items. That's something to consider. How big and bulky is it? And because you're going to have a lot more motion, you're going to have a lot more back and forth and moving, and you're going to have potentially the impact of everybody else. It's in everybody else's way. So you have to think about that. And is that you see how these are not mutually exclusive? They kind of tie together. So that extra motion and moving back and forth, is that giving you extra processing steps, extra steps in your operation of what you want to do? I'm going to say likely it is, especially with the other trades that it's going to be likely interfering with. Oh, we'll put it in this other room, it's empty. Meanwhile, that's the room the HVAC sub wants to get in 5 weeks, right? And you've got it 52 days extra. So big differences, a lot of impacts going across the differing areas. And I hazard to say we can definitely get into the defects, maybe not so much this one, the weight, the transportation, inventory, motion, extra processing, and then I'm even going to bring in the non-utilized talent. If you didn't really check with the GC and the other trades, because this is what happens sometimes on projects. A trade gets a whole pile of stuff delivered and the GC didn't fully comprehend the size of it. Of course, a lot of GCs do, but if you didn't, you got this surprise and like, what are we going to do with this now? And that's very often a trade optimizing for themselves, not the overall project. So just to think about, this is just one example of first order consequence. Shiny object, $15,000. We can check it like I showed you. You can check it in a lot of different ways, but Microsoft project was an example. And thinking through the possible impacts. And it may not look quite so shiny. So understanding first and then second order consequences. Hopefully that's given you a little bit to think about. Really thinking on these terms and learning to think on these terms. It's a skill set, and when you build on that skill set and you understand what's waste and what's not, then we're on the road to improving the construction industry as a whole. The construction industry as a whole has around 35% waste. This is what most of the data points to. In some cases it's more, right? Especially if we talked about the actual management processes, meaning necessary value-added waste, right? We've got a long way to go, but I hope we'll get there slowly. And you don't have to be perfect, you just have to keep getting better. I'm Tom Stevenson, hoping you have a wonderful day, and we'll see you next time. Bye for now.